In the last few videos, we've seen how we can take a PDF formula and use it to get, at least approximately, get a CDF graph and use that CDF graph for inverse probabilities on a continuous distribution. This video, we're going to kind of reverse that. We're going to see how to go from the CDF formula to get a PDF graph. Okay? So remember, we can get probabilities from either the PDF or CDF. For inverse probabilities, we need the CDF. So if we're given the CDF formula, we really don't need the PDF to find either probabilities or inverse probabilities. So if that's all you need, there's no need to do what we're going to do in this video. However, the thing that we need the PDF for is computing the mean and standard deviation. So that's really the only reason we really need a PDF, unless we just want to see it, which is kind of cool. So what if we're only given the formula for the CDF? Can we still compute the mean and standard deviation? And again, the answer is yes, we can, if we get the calculator to at least approximately give us the PDF. And we're going to see how to do that. Okay? All right. And we're going to use the fact that the PDF is the derivative of the CDF, and there's a built-in derivative approximator. So the way you do this is you put your formula in Y1 like this. Here's an example. Here's the CDF. This is the CDF formula that's in Y1. And what you'd put in Y3 is the derivative of Y1. And you don't have to worry about what that all means, except that Y3 will be the PDF if Y1 is the CDF. And you also need to know where to get that. It's Math 8. Okay? And so you find it's Math 8. Now, if you got the older operating system, it'll look like this. NDERIV of, you put in Y1, X, close parentheses, done. Y3 will be the PDF if Y1 is the CDF. Okay, on the newer operating system, you put in Y3 as, when you push Math 8, it looks like this. You put in the X here. Both of these will put in the X down here, and then the X over here, and you put in the Y1 in here. And again, Y1 is the CDF, then Y3 will be the PDF. And this one I hit graph, I had to pick the appropriate window. Here's the window you can try. And here the thinner one in this case is the CDF. You can tell that's the CDF, right? It goes from 0 to 1. And then the PDF is going to be a 0 on both ends, so it kind of levels out like that. And you see it's the thicker one the way I have it turned on here. Okay, so I want you to stop. If you got a TI-84, stop and do this yourself. Kind of press pause and work this out. Okay, here's the same thing more or less on the Inspire. What I did is I used a function. I had CDF of X set up as coming from a PDF. So I want to set up a different CDF. So this time I'm going to call it CDF1. So here I have a formula. I stored it as CDF1 of X. And then I went to my menu and said the derivative is this one right here. We use this one over here for the integral. This is the derivative. Hit that. And then I put in the derivative of CDF1 of X stored as PDF1 of X. So PDF1 is the PDF that goes with the CDF1. So pretty easy. And to graph them, and then I put PDF1 of X and F1 of X and CDF1 and F2. And they graphed with my normal colors. PDF1 is in blue and CDF1 is in red, and I have both of them graphed. Luckily, this is still an approximation, but it's a little faster than going the other direction on the graphing. All right, now the whole reason for do this is to find the mean and variance. Otherwise, we just use the CDF to find probabilities and inverse probabilities. We don't even need the PDF. But if we want to find the mean and variance, we need to do that. So the mean is the expected value of X. So you have your formula in right here. Okay. And you, the first thing I did here is, so there's our formulas like we had them set up, or down here, depending on which operating system. Actually, this one go across the top of the older operating system, across the bottom is the newer one. So let's look at the bottom here. So if you just integrate from -10 to 10 y3 of x dx for this particular function, that turns out to be 1. Technically, it goes from -infinity to infinity, but -10 to 10 actually is good enough to get you 1 here. So when I go from -10 to 10 of this, Notice I get 0 to like 9 places or so. So the actual value really is 0. Okay, and that's approximately 0. That's 0.9 zeros and then a 2 point whatever negative. Okay, so that's practically 0. So that's the mean. And so then when I want to find the variance, I integrate. So that was integrating x times the function. Y3 was my PDF. So when I integrate my PDF, I should get 1. And that kind of helps tell me I've got limits that work okay. And I want to integrate x times that PDF, same limits, I should get the mean, or at least real close to it. That's 0. And then when the variance, I want to integrate x minus the mean squared times the PDF. Same limits work. And that's at least approximately the variance. Square root of that, there's the standard deviation right there. Looks like this in the older operating system. On the Inspire, it looks something like this. Same thing, I've got my PDF stored as PDF1. So I do x times PDF1 of x dx, going from negative 10 to 10. That's 0. Works out exactly 0 on this calculator. Then I do x minus 0 squared times the PDF of x. And there's the mean, at least the variance approximately. Square root of my answer gives me the standard deviation. So what can we find with the CDF? Probability and inverse probability. What can we find with the PDF? Probability, and then the mean and standard deviation. Okay, that should clear up it finishes for, unless I add something later, this should be the slides that need to cover for homework set 3.2.